In this video, we're going to learn about the Bohr model of the atom and learn how to draw representations of atoms of different elements. First, we'll take a quick little look at the history of atomic theory. So we'll take a look at ancient times, what they used to believe then, what Dalton believed, what Thompson believed, and then finally what Bohr believed. In ancient times, people believed there were 4 elements, and those elements were earth, fire, wind, and water. And they believed that everything on earth was made of a combination of those 4 elements. John Dalton was a scientist in the 1800s, and he thought the atom was a small, hard, indestructible sphere. And to him, atoms would have looked like marbles or billiard balls, so shapeless, like featureless spheres. J.J. Thompson was a scientist in the late 1800s, and he believed that the atom was like a raisin bun. So the majority of the atom was positive, and that would be the bun part, and then there were small negative electrons embedded in the bun like raisins. Now he called it the plum pudding theory, but we understand raisin buns better than plum pudding. Finally, there was Niels Bohr, and he believed the atom was like the sun and the planets orbiting around. So the nucleus to him was the sun, and it was positively charged. And then the electrons were like planets, and they orbited the nucleus. Now we're going to learn how to draw Bohr diagrams. So the first thing we do is we draw a circle to represent the nucleus. Then we write the number of protons and neutrons in the nucleus inside that circle. Then we draw individual electrons in orbits around the nucleus. So we count the number of electrons, and only 2 fit in the first orbit, and then 8 fit in the second orbit, and then 8 fit in the third orbit, and we continue on drawing orbits. Okay, so we're going to do the Bohr diagram for hydrogen first. So again, we're going to have to go back and take a look at the atomic number and the mass number to figure out the number of electrons and protons and neutrons. So our atomic number for hydrogen is the first element. So it has 1 for the atomic number. And the mass number is also 1, which means that there are 1 proton and 1 electron. And then for our neutrons, it's 1 minus 1 equals 0. We don't have any neutrons because there's only a mass of 1, and the mass of the proton takes up the whole mass. So now we're going to draw our circle. So we'll draw a circle, and inside we'll put the number of protons and neutrons. And we can write the symbols instead of writing 1 proton. So it's 1 p and 0 neutrons. And now we're going to draw circles for orbits. And remember, 2 electrons fit in the first orbit. We only have 1, so we're just going to draw 1 electron. And that is our Bohr diagram for hydrogen. Now we'll try the same thing with lithium. So lithium has an atomic number of 3 because it's on the far left. And it has a mass number of 7. So we know that there are 3 protons and 3 electrons, but the number of neutrons we have to figure out. So 7 minus 3 equals 4. So we have 4 neutrons because the mass number is equal to the number of protons plus neutrons, remember. So now let's draw our Bohr diagram. So we draw our circle, and then we write 3 protons and 4 neutrons are in the nucleus. We draw 1 orbit, and remember we have 3 electrons, but only 2 electrons fit in the first one, and we like to space them out as far apart as possible, so we'll draw them like this. And then we draw another orbit like so, and we put our last electron. So I'll just stick it here, but you could stick it really anywhere. Now let's try with sodium. So sodium is also on the left-hand side, if you look down below lithium. So our atomic number for sodium is 11. And the mass number is 23. And the number of protons is 11, and so is the number of electrons. And our number of neutrons is equal to 23 minus 11, which is 12. So for sodium, we're going to draw the circle. So there's 11 protons, and there are 12 neutrons. And now let's start filling our orbit. So we draw one orbit, 2 electrons fit. Then we haven't used up all of our electrons. We still have 9 left. So we draw another ring. And if you remember, 8 electrons can fit in that second ring. So what I like to do is space them out in quadrants first. So 1, 2, 3, 4. And then you can either space the other 4 separately or put them in pairs. I like to pair them up. So 5, 6, 7, 8. That's 2 plus 8 is 10. We still have one more electron to put on our diagram, so we have to draw another orbit and then draw one more electron. So that is sodium. Our last example will be oxygen. So oxygen, if you remember, has an atomic number of 8. And oxygen is found up near the top right. And the mass number for oxygen is 16. So we have 8 protons and 8 electrons because that's equal to the atomic number. And then our number of protons is equal to 16 minus 8, which is 8. So now we're going to draw the Bohr diagram. So we draw our circle, and we put the protons and neutrons on the inside. So 8 protons and 8 neutrons. We draw our first orbit, 2 electrons. We have 6 left over, so now we're going to draw our next ring. This time I'll space them out. So 1, 2, 3, 4, 5, 6. That makes 8 total with the 2 in the other ring. So there's a representation for oxygen. And that's how you draw Bohr diagrams.